Welcome to solverfy.
All right, so for this problem, we're just going to call this procedure ternary. And ternary takes in a list of integers. So some n number of integers. All right, and there's at least going to need to be minimum of one of them. All right, and then we also have the search algorithm, the item we're searching for, which is also an integer. Okay, so first we want to define our search interval. So we'll set I equal to 1 and j equal to n. So I is going to be the position of the first element of our search interval, and j will be the last element of our search interval. So at the moment, we've just initialized it to the entire list. Okay, and so then we'll consider the case for while I is less than j minus 1. Okay, and so this ensures that the algorithm would stop when there's at most 2 elements in the search interval. We also want to define a couple of new variables. Okay, so lots of definitions here. So let's let L, lowercase l, be equal to the floor of I plus j divided by 3. Okay, and we're going to do essentially the same thing with u. Okay, so it's going to be the floor, except it's going to be 2 times I plus j divided by 3. And so these are also setting positions in our list. Okay, so then we can determine in which subinterval x lies, right? So if we think about all these variables, if we have a list, so a1 all the way up to al, it's going to go all the way up to au, and then up to a sub j, right? So we're just sort of creating roughly evenly distributed intervals here. And so to find in which of these subintervals x is in, we will then assign the boundaries of each search interval to these values of these subintervals, right? So let's say if x is greater than or equal to au, then we'll set our left interval, our ai, equal to 1 past that, right? So then we'll say u plus 1. So basically, if x is larger than this element, then we're going to start our search at the next element. Okay, but then we want to do the same thing. Like, what if x is between L and U, right? So we want to say, well, if x is greater than or equal to AL, then, and in this case, we need to set I and j. So we need to set I is equal to L plus 1. But we also want we want to stop it at AU, right? So we'll also set j equal to u. So that way it's not going to search from L forward, but rather just only search between L and U. And of course, lastly, it could be in this first interval, right? And so if that's the case, then we'd say else set J equal to L, because our I is already initialized at the first one. Okay, so the thing is, this is all in this while statement, right? So it's gonna, once we narrow it down to one interval, it's gonna re-split that interval up and do it again, and it'll split that interval, the new interval found up, and again, up until we no longer have the property that I is less than J minus 1. Okay, so that'll leave us with an interval containing at most 2 values. So I'm going to continue into this right side here. And so we just need to check if x is one of the values left in our search interval. Okay, so we'll say, well, if x is equal to ai, then we can set the location equal to I. All right, and then we have else if, and this one over here really should also be an else if statement. Else if x is equal to aj, the potential second item in this list, then similarly, we'll just set the location equal to j. And if neither of those cases occur, we'll just set the location equal to 0, which there is no 0 location. So that'll let us know that x does not exist in this list. And lastly, we need to return the location. So it'll either give us a value or a 0, the location, or an indication that it's not present.